Welcome to this video where we're going to look at finding the nth term rule for an arithmetic sequence, or a linear sequence as it's also called. Okay, there are 5 examples of linear sequences here. And a linear sequence means that to go from one term to the next, you add or subtract the same number each time. Okay, so if the sequence is ascending like this one is, you're adding on each time. In fact, you're adding on 3, aren't you, each time? Okay, to get from one term to the next, you're just adding on 3. That's pretty easy to see. Okay, and what we do is we look for what we call the 0th term. In other words, what term would go there in front of the 5 if we were to go backwards through the sequence? Well, clearly it would be 2. Okay, now when we talk about the nth term, we're talking about the position in the sequence. So n is the position. So here, for example, n is 1. That's the 5. It's the first number. The second number was 2. The third number 3, and so on. The 14 was the 4th term, and the 17 was the 5th term. Okay, so we call this one in front that we've just found, the 2. We call this the 0th term. Okay, if you can just remember that rather strange word, the 0th term is the one right at the beginning of the sequence before the first term. All right, so once we've found the 0th term, we look at the difference, which is 3, and the general rule is written like this: 3n plus the 0th term plus 2. And that's the rule for this sequence, and you can check it works. When n is 1, we get 3 1s are 3 plus 2 is 5. When n is 2, the second term, 3 2s are 6 plus 2 is 8. When n is 3, 3 3s are 9 plus 2 is 11, and so on it works. Okay, and of course you could use this rule to find, say, the any term you like. We could find the 50th term. Okay, the 50th term. Now it would take a long time to write the sequence out, but how would we do it? Well, we just simply put 3 times 50, okay, plus 2, and that is equal to 152. It's as simple as that. Okay, now in the second one we do exactly the same sort of thing. We've just find the 0th term, and that would be well, we're noticing it's going up in 6s. Okay, so we go down by 6 to give us -4. So it's going up in 6s, so it's 6n plus the 0th term, which is -4. Okay, and that's the rule for that sequence. And again, if we wanted to find, say, the 100th term of this sequence, the 100th term, let's just do that in this one. Find the 100th term. Okay, all we would need to do is put n equal to 100 in that formula. Okay, and that would give us 6 times 100, which is 600, take away 4, 596. Now, of course, it would take you a long time to write the whole sequence out for 100 numbers, but you can do that straight away. Okay, now this one, the sequence is descending. So instead of starting with a positive number, we start with a negative number. So it's going to begin with -7n, all right, because it's going down in 7s. But what's the 0th term? Well, it's the one that would appear before here. Now, of course, this time it's bigger than 91, it's 98, because that's what would have happened immediately before the 91. So the formula is, or the nth term expression is -6n plus 98. Or you could write that as 98 minus 7n. Okay? And you could use that again to find any term. So let's suppose this time we wanted to find the 10th term. find the 10th term. Okay, what would we get? Well, we would simply get 98 minus 7 times 10. In other words, 98 minus 70, which is 28. Okay, and if you continued that sequence, it would obviously go past 0 and start to become negative. Okay, next one. Well, this has got fractions in it, but that doesn't matter. You just do exactly the same. It's going up by 6/8 each time, right? 9 plus 6 is 15. 15 plus 6 is 21. Okay, and therefore we just carry on going up in 6/8 or 3/4. So it's going to be 3/4 of n. Okay, I simplify the fraction. But what's the 0th term? Well, if we go back 3/4 or 6/8 from there, we would be at minus 3/8, wouldn't we? Negative 3/8. So that's the nth term rule for that one. Okay. If you wanted to find, say, the 100th term of this one, find the 100th term. Okay. Well, let's just have a look what that would be. It would be, just tidy that up, that would be 3/4 of 100. Okay, minus 3/8. Well, 3/4 of 100 is 75. 75 minus 3/8 is going to be 74 and 5/8. Okay, you could leave it like that or write it as a improper fraction. It doesn't matter, but that's the value it would be. And last of all, we have another sequence which is ascending, but it starts at negative numbers and they're decimals. That doesn't matter. The same thing applies. I notice that it's going up by 1 point. Now, it's going up by 1.4. All right, it's easier to see when you go down. If you go from 0.5 to 1.9, that's negative, down 1.4, down another 1.4 to 3.3. Okay, and down another 1.4 will take you to negative 4.7. All right, so it's going to be negative 1.4. No, it's going up, so it is plus 1.4. Okay, not negative. Okay, the 0th term is negative, so it's 1.4n. Okay, and the 0th term would be 1.4 further down from here. So from negative 4.7, you go to negative 5.7, negative 6.1. Okay, it's more difficult to follow with the negative numbers, but that's what you would get, wouldn't you? Okay, negative 6.1. Now let's just check it for one of the terms that we already have. Let's see if it works for the 4th term, right? Because we've got the 4th term to be negative 0.5. So let's put n equal 4 into here. Okay, so we're checking this. Check. Okay, just to see that it works. Check. N equals 4. Okay, gives us 1.4 times 4 minus 6.1. Now what does that give us? It should give us minus 0.5. Well, 1.4 times 4 is 5.6. Yep, which is 5.6. Take away 6.1, which is indeed the same as negative 0.5. All right, and it would work for any number in that sequence. Okay, and if you wanted to find the, I don't know, let's say find the, let's say the 10th term. of this one, well, the 10th term would be equal to 1.4 times 10, okay, minus 6.1. Well, 1.4 times 10 is 14, minus 6.1 would be 7.9. Okay, so if you carried this sequence on until you got to the 10th term, you'd find that it would be 7.9. Okay, and that is an introduction on finding the nth term of an arithmetic sequence. In a later video, we'll look at finding the nth term of a quadratic sequence and a geometric sequence, and that's a little bit more tricky. Okay, that's it.